said it should do. Now, let's drive home a point. Imagine that we had actually done some bindings for x and p before we called it. In fact, let me go back over here to Python, and I'm going to say, let's set x equal to 3. Let's set p equal to 4. Let's set result equal to 5. And now let's call z as iterative power of, I don't know, let's make it 6 and 7. It runs through the computation, and notice what's happened. What's the value of z? Well, that is 6 to the 7th power. But more importantly, what's the value of x? Still 3. Value of p, still 4. The value of result is still 5. Those were bindings in a global environment. When I called the procedure, it created its own frame, its own context, did all the computation, and that local environment had separate bindings for x and p, which are not visible to the environment where we did the function call. So this point captures that notion of encapsulating the computation. And what that then says is, to say it in a little more detail, we have bindings for x and p up here. When we call the procedure, we do local bindings to the values passed in. We do local bindings for a result. And when we do that computation, the evaluation of the body only sees the bindings down here in E2. So we created a black box. Details don't matter. I can reuse this procedure anywhere by simply using its name. If I decide to change, for example, the names of the parameters in here, I'm free to do that, and it doesn't change any computation that relies on just using iterative power. So procedures do give us this one